TCP dump will collect packets and put them in a PCAP, but I don't think it will reconstruct files. If it will, that's a feature I don't know about. It has a lot of command line features, but I don't think it'll do it. I think you need an analysis tool. But maybe, if you find a way, let me know. So this here is one of the things that makes me very happy to be using this book. This is really important stuff, and it's not been covered in any other kind of textbooks I've known, which is, this is the kind of stuff you hear all the time. People go to school, and they think they're smart, and when you put them on the job, they don't know many things that are necessary. And one thing is the tools that are actually used by big business now to monitor their network. People don't just have PCs one by one. They've got large fleets of them, and they have to manage things. So there's a lot of infrastructure services. Now these ones you know about, but it's good to know how they work a little better. DHCP and DNS. DHCP distributes the addresses, and that is a pain because that means devices have changed their address every time they reboot, most commonly. And so that means if you have an intrusion event where you see something like botnet command and control servers going to an IP address, you don't know which machine that goes to. So that's annoying. UDP uses UDP port 67 and 68 to request an address and get an address. And that creates a DHCP lease, which by default is something like 8 days long, but in practice, it's terminated when you turn off the machine. And then someone else might get that address. So you need DHCP logs. And one of the logical things you're going to do with that is search for an IP address to find out what system had that IP address on a certain date when something happened. Or once you find a MAC address, you'll get a list of all the IP addresses that machine has ever had. So this would be if you're working for an event, you have a date. This would be if you're working from a machine and you have a MAC address. And both of those are important, and you can't do either of them without the DHCP logs. Unfortunately, Microsoft's DHCP logs are not as useful as they should be. The DHCP server, it stores logs, they're plain text logs, and they have all the information you need, but they're only retained per 1 week. By default, it just has 7 log files, and it raises it every week. So unless you have thought to improve that, it's very likely that by the time you're analyzing an incident, the log is already gone. All right. Then if you're on Linux, ISC is the company that made the most popular DHCP server, and this is just an open source product. It puts its logs in syslog in the local 7 delineation, which is something you can configure in syslog. Syslog is where, it's like Windows Event Viewer. It's where general logs about the system go. If your product does not bother to make its own log file, it can just send stuff to syslog, and then it will appear in var, that's var syslog? I think it's var syslog. Anyway, you can view it with a variety of viewers. And so here's some syslog examples. You see it got a DHCP hack and a DHCP inform. There's a series of like 4 messages going back and forth like a handshake in DHCP. But the important thing for us here is you see it has the IP address and the MAC address, which is what you need, tying those two together. And it also has a date and timestamp so you can tell when somebody got that lease, and therefore if you see some network event on the IP address, you can find out which MAC address it goes to. Of course, that's not enormously helpful because MAC addresses are essentially random, but that's life. You can scan your network with a variety of scanning tools to correlate the MAC addresses to real hardware. But anyway, so here's the DHCP log examples. They often store different things. There are like 4 or 6 exchanges in DHCP. This one stores the discover and the offer. This one has the request and the ACK. There are different parts of the handshake you can choose to log, but they all have the same general information. They tie the IP address to the MAC address. Now DNS is of course essential and much maligned. That's why we have a DNS security class here. There's a lot of things that can go wrong with DNS. The point of it, most of the time, is to take an alphabetic name like ccsers.edu and find the IP address. There are other uses, but that's the main use. So the DNS logs, like I was demonstrating right before class, are a very simple way to find out everything everybody is doing. Every single URL they connect will appear in there, and you'll know the time and you'll know the source IP address. So you have a list of all the domains someone has visited. Malicious servers change their IP addresses very frequently, and it'd be easy to catch here. Another thing I saw about a month ago, a nice script. You can tell malicious servers because they have random names, and random names have more entropy than human names, so you can actually tell quite easily with a simple mathematical test whether a name is random. Anyway, so Bind has always been the world's most popular DNS server. It was the first, it's been around forever. Berkeley Internet name domain. By default, it doesn't keep any logs at all. So you can turn it on in the configuration file, and if you do, you can then log queries. This IP address came in and made a query and got that answer. And that would be helpful to know what everybody's doing. Microsoft DNS is what Microsoft shops use. They kind of have to if they're using Active Directory. It also has no logging. You can turn it on here and choose what you want to log, incoming, outgoing, and so on, and then you'll see a text file with the things you chose to log here. All right. DNS servers seem to be heavily burdened. Microsoft DNS servers in particular are amazing. My DNS class people put a DNS server on a machine that's doing absolutely nothing, and it will time out. Like the first 2 times, it takes like 6 seconds to answer the question, which is always the thing. Microsoft software is just unbelievably inefficient. It uses twice as much RAM and runs 10 times slower than Linux. That was the old school stuff. Microsoft greatly improved that with Vista and Windows 7 and Windows 10, but they never improved their DNS. Their DNS server is still a relic from the bad old days when Microsoft just didn't care about efficiency or standards or anything. So one thing you might do is you might just capture this on the network. Instead of trying to capture it on the DNS server itself, you can just record the DNS packets as they go by. This would also be useful in case people use cloud-based servers like 8888 or 208.67.220.220, which is OpenDNS. Your company might even have decided to outsource your DNS to a cloud-based server. OpenDNS lets you have malware blockage, and you can even block certain domains, and you can even log who's trying to go to domains right on their cloud service without running any servers. So if you've done that, then the only way you can log them yourself would be on the network, although you might trust their logs at their end if you paid for their service. You can record the logs with any packet capture utility. You could use Wireshark, but you can't really turn on Wireshark and leave it on for days. Wireshark is too much of a memory hog. It will fill up the RAM and crash. TCP dump you can leave on forever, just sending it to a file, and it even has options to send it to a rotating set of files so it doesn't fill up the hard drive. And there's a special tool called DNS cap that will capture PCAPs. And you can set it to just to create a log file that just has a summary of each query, or it can save the entire PCAPs of all the DNS traffic if you feel like you want that. So that's a good thing to know. And I got a few iClickers about that. I put the iClickers over here where there's more room, so if you need one, come grab one. And I didn't put out the paper to write on, but it's in there. Anyway. Yeah, I'll hold it up. Yeah, there's the paper. There's a pen. I'll get my app going because it has a delay for some silly reason. All right. So, which one of these makes your IP addresses change frequently? I'll quit at 30. Looks like 25 would have been enough. All right, that's of course DHCP. All right, and it's out addresses, and they change frequently. Which one uses UDP 68? Looks like I quit at 25. All right, and that's again DHCP. Aha. People are reluctant to use the same answer twice, but you should know because DNS is on port 53. WINS might be a mystery, but WINS is the really old competitor to DNS Microsoft used to use. It's not used much anymore, unless you're really pervert. Anyway, so, all right. Which one retains item logs only for 1 week? quit at 25. I guess I better wait till 30. Some are still coming in. All right, and that's Microsoft's DHCP.
You gave it away last time.
Did I?
No, I didn't.
Yeah.
I'm just joking.
Yeah, I could have.
I picked wins last time.
Oh yeah. Well, it's not wins.
No, last time.
Yeah. All right. Anyway, so all right. Which one came from UC Berkeley? I'll quit at 25. All right, and that's bind, that's what it stands for, Berkeley Internet Name Domain, I think. ISC is the name of the company, but it came from Berkeley originally. All right, so then we get down to the commercial stuff, which is real popular at big corporations, and you don't see much of it at colleges that are cheap. But you have to manage all the devices in your network. You have to add things up, and these are big ones. LANDesk and Symantec's Altiris. LANDesk has a software license monitoring. This is something you're kind of forced to do now. If you get something like Microsoft Office or Photoshop, they aren't willing to just trust you that if you bought 10, you're only going to install 10. They want to have some continuous monitoring on your network, reporting that we're really only using 10. And so the software license monitoring is one issue here. You want to keep track of everything everyone runs. And you'd like to, this will actually put an agent on every machine and notice everything that launches, like the prefetch folder we've talked about, but it keeps it forever. So if somebody brings in program from home and installs it and launches it, you still know what happened, which is what you really need because the company's responsible for anything that happens on their network. So that's pretty handy. And of course, it's good for attackers. Attackers have a workflow that is quite different than legitimate users. They typically download a bunch of hacking tools, unzip them, run them once, and then delete them. So never used again, whereas real workers typically have some application installed by their IT department, like Microsoft Word, and they use it every day for years. So you'll see quite a different pattern here, and you'll see that in there. Even if you delete the binary, the LANDesk will still have a record that somebody installed it, and they will keep track of what the executable was after it's gone, just like the prefetch folder. I don't think that removes anything just because you deleted the binary either. So this product stores this information in the registry, which I must say I regard as kind of rude. You know, the registry does have a maximum size, and you can fill it up, and then you can make it bigger. But if someone had asked me, I would have said, don't put log data in the registry. But they didn't ask me. That's where it's going. So it's got sub-keys. Inside this monitor log key, it makes a key for every app, giving the whole path in there, like C program files, Microsoft Office, and all that jazz. And then it has keys in there that contain all these things: current duration, current user, first started, last started, and so on. So there's a tool called SLM Browser that you can run on a machine that has this product installed, but you can't run on an exported registry keys. So if you have a forensic image and you've used something like FTK Registry Viewer to view the registry, you can't run it on that, which is not much use to us. They think you're going to run it on the machine where it's installed, but we're usually working with copies of machines. So RegRipper is the tool that does it. RegRipper is pretty cool. A tool that lets you harvest keys from registry. The registry, in addition to many other annoying features, is binary. It's not just plain text or anything, so you can't just grep it or easily parse it. You need some kind of tool to open it first. So things with low total runs might be attacking tools, because normally anything in an office would be used many times. Things with suspicious paths, like if anything's running from the recycle bin, or if they're running many different tools from the same directory, the attacker will typically download a kit of tools in a RAR archive or something, and then unzip it in a folder, and then run a bunch of these things, and then throw it all away. I didn't know you could run something directly from the recycle bin, but I haven't tried. I know I heard years ago, about 10 years ago, I heard about people that would get infected, and then their machine would start serving up kiddie porn from the recycle bin. So it's a place attackers do hide things, and there are ways to use files from there. So it's an obvious place where nothing legitimate would be. You can also look for timeline analysis, look for many things run in a short time period that are not normal, like net, CMD, and AT. Net is how you create a new user at the command line, net user. And at is how you schedule something to start in the future. And these are things most people do not do from the command line. They do it from control panel. So if you see a lot of command line tools, it's probably somebody's batch script that's probably an attacker. And these ones indicate lateral movement, where you're connecting to local area network shares and then putting something on there. You can look for current usernames that shouldn't be using that machine normally, or usernames that have only run a small number of applications, so they're not really an employee, they're an attacker that only used it briefly. And of course, elevated privileges always need to be examined. This is one of your standard security tools, should be an elevated privilege audit to see what the elevated privilege people have been doing, because they're the most dangerous people. And you can look for executables that aren't there anymore. That would pretty much be a clue that something's malicious, unless of course it's an installer. People normally run an installer once and then throw it away, but anything else, if it's on there, they typically run it frequently. Then Symantec's Altiris does more or less the same thing. It does not meter applications this way by default, but you can turn on an optional component to do it, and then it will store a history of all these things. Let me see if there's anywhere to move this thing to get it out of the way. Maybe that will do. All right. So, all right. And so it keeps track of the events, and it also has the ability to deny them. This is like Microsoft's App Locker, I think. Microsoft can also limit applications with software restriction policies by either name or path or MD5 sum. And this product can do that too. So the log is a plain text file, and it's got the date of first execution, date of last execution, run count, and total run time, the same kind of thing, and also the manufacturer and the user and so on. So you know pretty much what you would have gotten from the prefetch folder. You know exactly who ran it and when they ran it, and how many times they've run it. So here's things to look for. Executables that don't have a version are probably something nasty like hacking tools, because if they used any kind of normal tool like Visual Studio to compile it, it would have put something there. If there were any kind of commercial product, they would have. I'm pretty sure Visual Studio puts in a version number even if you don't type one in, although I'm not sure. Maybe developers out there will know. But bad guys typically strip that stuff away, because a lot of antivirus engines just look at the metadata. And if it is a known product and a known version, they call it bad without looking at the contents. So it's a trick. Another thing people will do is make many copies of the same executable to put backdoors all over the place with different names. And so you can find files that are exactly the same except for the name. And that's another clue that's probably a bad thing. And then, of course, antivirus. Maybe until 4 or 5 years ago, people really trusted their antivirus. They really thought it meant no viruses were getting on the system. Pretty much everyone has given that up now, and they realize that even if you're running antivirus, that doesn't at all mean there's no bad stuff on the system. It's just stopping the low-hanging fruit. So the big ones are Symantec, McAfee, and Trend in enterprises. Symantec's been around forever. But in general, the thing about antivirus, it doesn't detect everything. It only detects the things it recognizes as malicious. So if the hacker doesn't use malware, antivirus won't do anything, and you don't have to use malware. A lot of attacks, I was just hearing, I was at the High Tech Crime Investigators Association meeting, and they said a lot of attackers now use no malware. Some large percentage, I think it said something like 80% of attacks don't use malware. They just find something like a default password or another, and they come in with that, and then they use standard utilities to take over your stuff. That's what the UFO hacker did, Gary McKinnon. He stole stuff from the NSA. He wandered through the network for 2 years trying to find proof that there were UFOs in Area 51. And he did all that because they had a Windows XP machine on, logged in permanently as name administrator with the password of PASSWORD with the remote registry turned on, and he just connected to it with regedit and ran commands on it and was in. And so did the Chinese, and so did the Russians for 2 years, always using this machine, and nobody noticed inside the NSA for a while. That's why, the military has all these rules, and every year they also have an audit to see if they're obeying the rules, and always everybody is wildly out of compliance. There's what's supposed to happen, and what's really happening is way, way behind it. Anyway, so that's an issue. Also, of course, there's malware that doesn't match a signature, and the antivirus doesn't find it. If you use any hacking tool for pen testing like Metasploit, it's all full of ways to sneak past antivirus, because everyone has to do that. So the logs are useful. You might see some malware coming in, and that gives you a clue when a bad thing happened, but be aware that you're probably not seeing the whole picture. You're seeing the tip of the iceberg. If it detected 3 or 4 viruses on that machine, probably a lot more was going on. Now, some antivirus just deletes files. It's a lot friendlier if it quarantines it. And here we find out how the quarantine works. What it does is encode the file so it can't run anymore and put it in a quarantine folder. And it's going to put it in an archive. This is the same thing people use to ship malware around for malware analysis. You just put it in a password-protected archive folder. Therefore, attackers often use these password-protected archive folders, probably not the quarantine. And if they do, then your antivirus can't scan them because it can't open it, and most antiviruses will log that as an error. I got a zip file, I tried to look into it, and I couldn't get in, so it'll log that, and that's a clue. that it might be able to find when the attacker's acting by the presence of those files. They can't be scanned. Semantic endpoint protection is the most popular one in America. It's got extensive plain text logs. It also puts events in the event log. I think this is probably because it's a very old product. They invented their own screwy way to record dates, which looks like a cheap imitation of Unix dates. They start counting dates in the beginning of 1970, like Unix, but instead of just having a number of seconds since January 1st, 1970, like Unix, they tried to make it friendlier and made it very strange. A byte for the year, counting from 1970, a month, but January is 0 instead of 1, so December is 11, and then the day, but the first is not 0, just in case you thought it was going to be consistent or make any sense. Then the hour, minute, and second, all in separate bytes. You have 6 bytes that encodes the date in a bizarre system unlike anything else. So this is what November 19, 2002 looks like, 2008-1308, you know, such is life. Then they make a quarantine file with VBN, and that is, there's 2 files. There's a metadata file that has metadata about it, like what the virus was, what time it was quarantined, and stuff like that. And then they have an encoded copy of the file where they just XOR it with 05A. That's a simple way to scramble all the bits so that it won't run anymore. Unfortunately, it's so easy to undo that they don't want to do it that way anymore, so the newer version also inserts 5-byte sequences in some pattern that no one really knows. So there's a guy that, they give you an extract thing that will extract files from quarantine, but you can only run it on the system that it was quarantined on. You cannot take a forensic image or copy it to the central server and extract it there, which is kind of screwy, but that's the way it is. And so if you want to extract a quarantine file, one thing to do, if you have a forensic image, it's an image of the whole drive, you can stick it in a virtual machine, mount it as a drive, and run it. And this is a trick you often have to do in forensics. Another reason you often have to do it is people are storing important documents in some screwy format, like WordPerfect, an old version, or WordStar, or some crazy thing that you don't have, and you can't open the file without that product. So what you do is you boot up the forensic image in a copy, run the machine, and then you have all the software that's installed on that machine so you can use it to open the files. Now, of course, doing that will contaminate the evidence, so you don't trust that copy as being perfect anymore, but you work on the copy. You still have the original to look at, but if you need an app like this, you can boot up the forensic image by just connecting it as a hard drive to a virtual machine. There's also a Python script somebody wrote to extract these things, but apparently it's not perfect. It doesn't really get it in the whole 100% right. Someone has tried to reverse engineer where Symantec is sticking in these extra 5 bytes and how to take them out again, and they haven't really got it. All right, then you've got McAfee, founded by this guy who now has nothing to do with the company and has said it's the worst product on the planet. So I'm sure that McAfee wishes this guy was not around to be the spokesman for their product, but he is. He really made this thing. But he's not going to be the president. He did run for president, but he seems to have given up when Gary Johnson beat him. So I think he might not be much different than the other guy running, but anyway. So, all right, so he has a bunch of logs out there. It logs applications that try to terminate it, buffer overflow attempts, and so on. The ones that are most useful for us are on-demand scan and on-access log. Those show files that are quarantined or deleted, and they have the name of the threat. And again, it creates events in event logs, so it amounts to about the same thing as Norton. It's got a BUP extension that has details for metadata, and then it has the file. And the file is XORed with 6A and then compressed in OLE. You can just open that with 7-zip or other compression utilities, not just WinZip, but OLE is just a Microsoft format. At least I've seen Microsoft use it. I don't know if they invented it. It's just another way to zip things up, and it's not that hard to open. And so here's the metadata. When you try to put the pwdump hacking tool on a machine with McAfee, and here's the original name, and here's the information about when it was detected and why they took it down. It's a known hacking tool. I noticed we used to have McAfee in the lab, and I would prepare the hacking homework, and people plug in a USB drive, poof, it's all gone. It just nukes everything it recognizes as a hacking tool. That was annoying. But that's, of course, what it's supposed to do. Then there's Trend Micro, stores logs locally on the host in plain text that look like this. Here's that pwdump again being detected, and it has a date timestamp, some information about why it, how it identified it as, and the full path to the file that it deleted. Yeah?
Password dumps malicious?
It's a hacking tool. It will dump out the password hashes. So it doesn't really have, it's not like a virus that spreads, but it's a hacking tool which no one at your company should probably be using except your security team that hopefully knows how to hide it. Yeah, it's not a virus, but most antivirus are triggered like Nmap. They'll probably detect Nmap and nuke it too. It's just something that typical corporation does not want everybody using because it's probably not used for any legitimate business purpose.
It comes out of the box detecting, being able to detect.
Yeah. Well, he's got online updates, of course. But yeah, and so it also encodes the files and gives you a product to decode them, VS encode, which you do in the command line here with the path to the quarantine files. All right, let me see if I can get these to work. There we go. That's not too bad. All right. So, which one has the 6-byte timestamp? I'll quit at 25. All right, that's Symantec endpoint protection left over from good old Norton antivirus.
You put Endpoint, but it should be Endpoint.
All right, good. That must be why so many people didn't get it.
Thank you.
Yeah, all right. Anyway, good. So, all right. Which one puts execution logs in the registry? Quit at 25. All right, that was LANDesk. And it may not be as bad as I thought because I don't think they log every time every app is run. They just log the first time it ran, the most recent time, and the count of how many in between. So it's not going to inflate the registry with quite as much junk as I thought. But anyway. All right. Which one makes BUP files? Quit at 25. I think that's McAfee. I'm going to flip back and make sure. Yeah, I thought it was. Yep, McAfee makes the BUP files. All right. All right, the most popular answer. Okay. All right. Which one of these is not suspicious?
Is this a trick question? No,
I don't think so.
I did a rule of elimination. I don't think any of it. I think all of them are suspicious.
Well, then you got a problem. But one of them I think is not suspicious. I'll quit at 45. All right. And that'd be the one in the middle. Whoa,
I picked that too.
very odd.
I picked B.
C is the only one that's not suspicious.
Wait, so the one
If you run an installer once and then discard it, that's normal.
Installer, not
Yeah,
running, executing.
that's right. Norton installers are normally only run once. All the rest of these are very fishy. There's no reason to have identical files. Yeah, right. What's that? Yeah.
It could definitely be B because
Yeah.
the MD5 won't change if you change the name.
It won't, but why would you have multiple copies of a file with different names?
Well, I mean, let's say you did a download and you're doing the same download, it's going to put like a little one after it or whatever. So it's going to.
That's true, but that's not normal that you have a lot of that. This is the one I think is a routine event. That's just, yeah.
Is C the answer because
C.
you don't run it, you just install it?
Well, you run it just once and then you throw it away. That's the normal way you use installers. This is completely normal. The rest of these are all weird to some extent.
But it could be a service. You could run it and then install it and then
You don't reinstall it over and over, though. You install it only once.
Starting it doesn't mean you uninstalled it, right? It could still be running in the background. You don't let it serve.
Well, those are executables, so they're not installers. Yeah.
What about hash collisions?
Oh, hash collisions are very rarely seen, even with MD5. You can arrange them with great difficulty, but you'll not see them happen by accident. That's a good point.
Well, why is D not the answer?
Why is what?
Why is D not the answer?
Oh, D. Because it's very strange to have a user that isn't doing any work. They would be running something. If it's why do you have a user account on a machine that's doing such a small amount of work. That's strange. It's possible that it could be innocent, like a temp that came in over, but it's worth looking at. I mean, none of these are perfectly strong evidence of evil, but if you have a user on a machine that is not running very many applications, then it's kind of strange.
But isn't C that indicative of a hacker installing something and then dumping it?
It could be, but it's also, every installer works that way. Everything installed had an installer that ran once and then went away. So, yeah, anyway, it's good that you people are thinking about it. And that's part of why these things are extra credit, because there's often argument about it. So let's take a break till 5 minutes after 7. I'll stop this thing. This is chapter 10, 121. Uh-huh.